There's a moment when you finally understand GPS that feels almost embarrassing. We use it every day. On our phones, in our cars, finding cafes, tracking deliveries. And yet the real reason GPS knows where you are is nothing like what most people imagine. It isn't satellites beaming down your coordinates, and it isn't some giant map telling every device, "You're right here." Instead, GPS works because of time. Ridiculously accurate time. Time so precise that even Einstein had to be invited into the engineering meeting. Imagine you're standing outside with your phone. Above you, around 20,000 kilometers up, there are about 30 GPS satellites constantly broadcasting a simple message, a time stamp. The exact moment the signal left the satellite, and the satellite's position at that moment. That's it. No coordinates. No directions. Just, here's where I was, and here's when this message left me. Your phone then compares that timestamp to its own clock and figures out how long the signal took to get to you. Multiply that time by the speed of light, and that gives you the distance between you and that satellite. If you know you're 20,200 kilometers from satellite A, that means you lie somewhere on an imaginary sphere around it. Then you do the same with satellite B, now you're on the intersection of two spheres. Add a third satellite, now you're down to just 2 possible points. Add a fourth and only 1 point remains, your location. It sounds simple, almost too simple. But here's the problem. For this to work, timing has to be stupidly precise. Light is so fast that if your phone's clock is off by just a millionth of a second, 1 microsecond, your calculated position would be wrong by about 300 meters. And your phone clock? It's nowhere near that accurate. This is where the satellites step in. Each GPS satellite carries multiple atomic clocks. Some of the most precise timekeeping devices humans have ever built, drifting maybe a second every 30 million years. They broadcast time that's so accurate your phone can correct itself just by listening. But even that isn't enough. Because the satellites are moving around Earth at 14,000 kilometers per hour. And according to Einstein's special relativity, fast-moving clocks tick slower. At that speed, the satellite clocks run about 7 microseconds slower per day. Meanwhile, the satellites are also really high above Earth's surface, where gravity is weaker. And according to general relativity, clocks in weaker gravity tick faster. That effect speeds up the satellite clocks by about 45 microseconds per day. Put both effects together and the clocks in orbit are ticking 38 microseconds, faster every single day compared to clocks on Earth. That sounds tiny, but if we didn't fix it, GPS would drift by more than 10 kilometers every day. Your location would become useless within minutes. So, engineers do something clever. They intentionally slow down the atomic clocks on the satellites before launching them. Once in orbit, relativity speeds them back up, and their ticking matches Earthbound time perfectly. In other words, GPS doesn't work unless your phone constantly listens to 30 clocks orbiting Earth, which are clocks that have been corrected for the warping of time itself. That's the aha moment. GPS is not a map system. GPS is a time system. Your location is simply the answer you get when you compare how long signals take to reach you from multiple clocks in space. The entire system works only because Einstein was right. Motion slows time, gravity bends it, and your phone quietly applies relativity every moment it's figuring out where you are. So the next time you open a map and instantly see a blue dot appear in the exact spot you were standing, remember. That dot is powered by the bending of space-time. If you enjoyed unraveling this idea with me, don't forget to subscribe. This channel is really a labor of love, and I'm trying to reach 10,000 subs. It only takes a second of your time. Thank you, and, as always, stay curious.